Hello friends, Mr. Burrell here. I've decided to record this extra help with homework problems video. So these are all questions from the 5.4 homework assignment. So if you've been struggling with some of the 5.4 homework questions, I'm going to go through just a few of them with you together here. So the first problem I'm going to go through on the homework is question number 4. It says 2 over x equals x plus 4 over 2x squared plus 3 over x squared. So remember, with these rational expressions, with these rational equations, I usually have something equal to something plus something else. And since they're all fractions, if I am to be able to deal with all these fractions, especially when I'm like adding and subtracting together, they need to have a common denominator. I'm not going to be able to do anything with them until they have a common denominator. So I'm going to break down each of these denominators into their individual factors. So in the bottom of this fraction I have x, in the bottom of this fraction I have 2 times x times x. In the bottom of this fraction I have just x times x. So notice, I'm going to change colors here, that if all of these denominators are going to be in common, this denominator is going to have a 2 and an x, and this factor is going to need to have a 2. In order to make all three of these fractions have the same denominator, that's what I'm going to need to include, the additional factors each of these fractions needs. So in the top and the bottom of this fraction, I'm going to multiply by 2 over 2. I need 2 in the bottom, so if I multiply by 2 in the bottom, I have to multiply by 2 in the top. On this fraction, I'm going to multiply by 2 and x on the top and the bottom, because I needed 2x in the bottom, so if I multiply by 2x on the bottom, I have to multiply by 2x on the top. So let me rewrite this expression. On the top here, 2x times 2 is 4x, so I have 4x over 2x squared, because 2 times x is 2x squared. Here I have x plus 4 over 2x squared. That didn't change because it also already had the common denominator. Plus 3 times 2 is 6 over x squared times 2 is 2x squared. So I got a common denominator straight across here. So, in order to solve this, because now I have a common denominator, I'm going to go ahead and ignore all the denominators and just solve using the numerators, or the tops. So I have 4x equals x plus 4 plus 6. 4x equals x plus 4 plus 6. So now this just becomes an equation to solve. So let's get all my x's on one side, all my numbers on the other side. I don't have any x squared terms here in the top, so I'm not going to be dealing with a quadratic expression. This is just going to be a linear expression, because I just have x's and numbers. So let's see, I can combine these together on this. So on this side, 4x equals x plus 10. I'm going to go ahead and subtract by x on both sides, like so. Because x minus x is 0, 4x minus x is 3x equals 10. Then since I have 3 times x, I'm going to go ahead and divide by 3 on both sides. So my final answer is 10/3, or if I were to write that as a decimal, that's going to be like 3.33 repeating, 3.3-ish. So my answer is 10/3. So I'm not quite done. I want to double check and make sure that my solution is not also, that I don't have any extraneous solutions, meaning that I don't have any excluded values that are also solutions. So before I simplified anything here, I had 2x squared, 2x squared, 2x squared. So if I set that equal to 0, if I set one of these factors equal to 0, I'm going to have an excluded value of x equals 0. So if I had a solution of x equals 0, that would be an extraneous solution and it wouldn't work. But my solution is not equal to 0, so I'm good. I'm done. My answer is 10/3. Okay, that's number 4 on your homework. This one's number 9 on your homework. I have 1 over r plus 3 times r minus 2 equals 3 over r plus 3 minus 2 over r plus 3 times r minus 2. So, before I do anything with any of the solving in this expression, I need to make sure that I have a common denominator. So here I have r plus 3 times r minus 2. Those are my factors. Here I just have r plus 3. Here I have r plus 3 times r minus 2. So these two are the same, but notice that this middle factor, this middle fraction here, is missing an r minus 2. So I need to multiply by r minus 2 in the bottom of this fraction here. Well, if I have r minus 2 that I multiply on the bottom, I better multiply by r minus 2 on the top as well. Okay, let's rewrite this expression with those changes. The first hasn't changed. 1 over r plus 3 times r minus 2 equals, I have 3 times r minus 2 over r plus 3 times r minus 2 minus 2 over r plus 3 times r minus 2. See that? Now I have all common denominators, and since I have common denominators, I can ignore those and just look at the tops of these fractions, the numerators. So I have 1 equals 3 times r minus 2 minus 2. Okay, now I need to simplify this and solve for r. So I'm going to go ahead and multiply through in these parentheses here. So I get 1 equals 3r minus 6 minus 2. Well, negative 6 minus 2. Sorry, I'm going to have 1 equals 3r minus 8. I need to get this r by myself, so I'll go ahead and add 8 on both sides. Now I'll get 9 equals 3r, because adding 8 cancels out that negative 8 there. Then I'm going to go ahead and divide by 3 on both sides, because r is being multiplied by 3. I divide by 3. So r equals 9 divided by 3, which is 3. So my answer is 3. That's my final answer, is r equals 3. But I better go back and double check that I'm not going to have any extraneous solutions. So before I simplified anything, here's what I had in the bottoms of these fractions. I had r plus 3 and r minus 2. I need to set each of those equal to 0 to find what my excluded values would be. So if I subtract 3 on both sides, I get r equals negative 3. Add 2 on both sides, I get r equals positive 2. So those are my excluded values. So if I had a solution of either negative 3 or 2, that would mean I have an extraneous solution. That solution's not going to work. But I have a solution of positive 3, so that's fine. So I'm good. My answer is just r equals 3. So that's question number 9. Question number 15. This is the last one we're going to go over. You recognize that there's a challenge section on your homework assignment. I would definitely encourage you to look into those questions. I'm not going to require them, but I would look at the challenge section of these questions. But 15 is towards the end of your homework assignment here. So I have 1 over r plus 3 equals 2r minus 1 over 2r squared plus 6r. Okay. So what I need to do is I need to look at each of these denominators, and I need to find what the greatest common factor would be. Before I can do anything with this equation, I need to make sure that all of my fractions have a greatest, or a common denominator. There we go. So I have r plus 3 here. I have 2r's here. This isn't in its simplified factored form, so I'm going to go ahead and take out a greatest common factor. I can take out 2 and r out of both of these terms, which leaves me with r plus 3. Okay, so notice this denominator has r plus 3, this denominator has 2r, this denominator has 2r and r plus 3. So my common denominator is going to need to have 2r and r plus 3. So here I need to multiply by r plus 3, here I need to multiply by 2r. So all of them will have 2r times r plus 3 as a common denominator. So here in the middle I need to multiply by r plus 3 on the bottom. And if I do that on the bottom, I better do that on the top. Here I need to multiply by 2r on the bottom. And if I do that on the bottom, I better do that on the top. See that? So I'm going to go ahead and do all that math here. So I'm going to write an arrow here. Here I have 2r over 2r times r plus 3. So I multiply by 2r on the top and on the bottom. Equals 1 times r plus 3 is just r plus 3 over 2r times r plus 3. So I multiplied by r plus 3 on the top and the bottom there. Minus 1, this one hasn't changed, over 2r times r plus 3. Okay? Feel good? Now that I have all common denominators, I can just ignore the denominators and just focus on the numerators. So 2r equals r plus 3 minus 1. So let's go ahead and simplify this. I can combine 3 minus 1. 2r equals r plus 2. I'm going to go ahead and subtract r on both sides and get 2r minus r is just r equals 2. So I get r equals 2 as my final answer. R equals 2 is my final answer. I want to go back here before I simplified and see if any of my excluded values match up with that solution. So when I set 2r equal to 0 and r plus 3 equal to 0, I get excluded values of r equals 0 and negative 3, neither of which are solutions that I got here. So I'm done. I'm good to go. Okay, so let me go ahead and I'm going to add another slide here. We're going to go ahead and do one more problem. This one actually is one of the challenge questions, so I lied before. I want to do one of the challenge questions. I want to do number 17, which is n plus 4 over n minus 1 over n squared equals 2n plus 2 over n squared. Okay, so we're going to solve this equation. I'm going to solve for n. So if I write all of the factors that are in the denominators here, I have n squared, n squared. So notice my first fraction is missing an n. I have to multiply by an n on this first fraction on the bottom, so I have a common denominator. So if I multiply by n in the bottom, I better multiply by n in the top. So that will leave me with n times n plus 4 all over n times n minus 1 over n times n equals 2n plus 2 over n times n. See that okay? So now that I have a common denominator, I can ignore the denominators and just look at the numerator, or the top of the fractions. N times n plus 4 minus 1 equals 2n plus 2. Okay, let's simplify this and try to solve. So I better multiply n into this parentheses, and I'm going to get n squared plus 4n minus 1 equals 2n plus 2. So notice what happened here. Now I have an n squared term. This is now going to be a quadratic equation. This is going to be a quadratic equation, meaning that I'm going to have to get everything on one side, set it equal to 0, and I'm going to have two solutions. I'm going to have two answers. So I'm going to put this in standard form. I better subtract 2n on both sides, which gives me n squared plus 2n minus 1 equals 2. Then I better subtract 2 on both sides, which gives me n squared plus 2n minus 3 equals 0. So since this was a quadratic, since I have an n squared term, I need to put it in standard form like this, right, with everything being set equal to 0. So this, again, is a little bit of a review from Unit 4. So now that it's in standard form, I need to find two numbers that multiply to make negative 3 and add up to make 2. Multiply to make negative 3, add up to 2. So 3 times negative 1 is negative 3. 3 plus negative 1 is 2. So if I write this over here, I have n plus 3 times n minus 1 equals 0. So hopefully this is bringing back some memories, right? Now that I have this in factored form, I'm going to set both of these equal to 0 and solve for n. So I get my solutions to be n equals negative 3 and n equals 1. Those are my two solutions, n equals negative 3, n equals 1. I need to double check back here before I simplified anything. I need to set my factors in the bottom equal to 0. So if I set n equal to 0, that would be one of my excluded values. But since n equals 0 isn't a solution I got, then I'm fine. If I did happen to get an excluded value of, say, n equals 1, for example, that would mean this solution would be no good. That would not be a valid solution because it would force me to divide by 0. But since I just had an excluded value of n equals 0, these are my solutions. If I were to plug those back in here, up in my original equation for n, if I were to plug negative 3 in for n, and then if I was to plug in 1 for n, you'd notice that indeed that works out. That equation is satisfied. So, that's all I got for you. I hope that was helpful. If you have additional homework questions for me, please let me know so I can reach out and set something up so I can help you. But again, I do hope that was helpful, and I hope that you enjoyed that as much as I did.